Okay, today we're going to practice extracting roots. It sounds like a really ugly thing, but we actually have already done it to some extent when we did square root functions. I'm sorry, quadratic functions. So extracting roots just means that we're going to simplify the numbers and the variables under the radical. We're pulling out as many things from under that radical sign as possible. And we're going to use our perfect square list to do it. When we get to cube roots, we'll use our perfect cube list. So let's start with an example, square root of 12. So 12 is not on this list over here. So we need to break it down into factors and find a factor that is on this list. Now if you remember, and some of the classes went over this on Friday, you can put in 12 divided by x into the y equals, and it'll give you your factors. And I'm not going to do this every single time, but let's go ahead and look at 2 and 6, 3 and 4. That's what you're going to find. Remember, you don't care about the decimals, and we're not going to pay attention to 1 as a factor because it won't change anything as we simplify. So we're either going to choose this set of factors or this set of factors. We've got to identify which set of factors has a perfect square in it. Well, this one has a 4, and 4 is in our list. So we're going to break this down into 4 times 3. I can break this apart, if you guys remember, from our square root rules that you learned before you came to my class. These two are the exact same thing. Okay? We can break those numbers apart. So the square root of 4 is 2. And the 3 is not a perfect square, so it's going to stay under there. So when we say simplify the square root of 12, we're going to have 2 square root of 3 as the simplified form because we've gotten as much out from underneath the radical as possible. Now go ahead and write this list on your paper because I'm going to move on and I'm not going to keep moving it along with me. So let's look at a second example. Square root of 48. Now for those of you in class on Friday that we did this, you're fine to move on to the next example. Again, you can put 48 divided by x into y equals and find your factors. So here are the factors, and I notice that I've got a 4 right here, but we've got a 16 right here, and that's on our list. So we're going to use this one because we always want to use the biggest square root. So this breaks down into the square root of 16 times 3. I can break that as apart as the square root of 16 times the square root of 3. The square root of 16 is 4, and 3 doesn't have a perfect square. So this is my simplified version. All right. If you need another one, here is the square root of 20. Okay, hit pause and then turn it back on to see the answer. I'm not going to work through it. Ask someone around you if you need help with it. So hit pause. All right, your correct answer should be 2 square root of 5. So let's move on and do some with variables. What if we've got the square root of x squared? Okay, this may be fine for you. You know that the square root and the x squared, they're inverses of each other, so they cancel each other out and we just get x. But what if we didn't see that? We could always take that x squared and put it in exponential form. And when we have a power raised to a power, we multiply. So 2 times 1/2 is 1. So x equals 1. So you could do that both ways. Let's try another one. Square root of x to the 4th. Okay, so we could do x to the 4th raised to the 1/2. Multiply these two. Half of 4 is 2. Let's do one more of these. Let's do the square root of x to the 6th. X to the 6th raised to the 1/2. 6 times 1/2, or half of 6, is x cubed. Now, what we realize is when we multiply 6 times 1/2, basically what we're doing is 6 divided by 2. And when we divide 4 by 1/2, we're basically dividing 4 by 2, and so on. So if you notice, if we have our indexes of 2 out here, the exponent divided by the index will give us our new number. The exponent divided by the index will give us our new exponent. Our exponent divided by our index will give you your new exponent. So let's see if you guys can do one of these on your own. Let's use the same rule, but let's change the index. So the cubed root of x to the 6th. Now remember, we're dividing our exponent by our index. So we've got x squared as our answer. Okay, I'm going to give you 2 more. I want you to hit pause and then turn it back on to see if you got it right. Okay, so do 8 and 9, hit pause, and then turn it back on to get the right answer. All right, your answer should be x to the 4th for number 8. And what happened on 16? Or on number 9? So 3 will go into 16 how many times? Evenly. It'll go in evenly 5, won't it? What is our remainder? What's left over? There's 1 left over. So that's going to stay under there. So I know. So let's do x to the 16th raised to the 1/3. So 16 divided by 3 is 5. And we have 1 left over. So x to the 1 is left under there. Now there's an easier way to look at this. We know that we need to break down, we know that x cubed, if we take the cubed root of x cubed, then we will get a single x. So let's break this down. We have got x cubed times x cubed times x cubed times x cubed times x cubed. This is 3, 6, 9, 12, 15. And how many x's do we need to make 16? A single one. So I have 1, 2, 3, 4, 5 x cubes. So that gives me my 5. But I have this one lone one underneath that has to stay under there. Threw a curveball at you. All right, so let's do some more examples and see if we can keep this going. Okay, I went ahead and put several examples here, so if you feel like you're getting it, you can hit pause, work them, and then fast forward to the answers. Otherwise, let's look at it. So we've got 2 separate variables going on here. So I'm going to do the square root of x cubed times the square root of y to the 4th. Well, y to the 4th is easy. We know that 4 divided by 2 gives us a y squared. Okay? But the x cubed is just like what we did before. We know that we have an x squared and then another x to make x cubed, right? So there is a single x squared, but there's still an x underneath there. The square root of this x squared gives me x. Okay, so that takes care of this, and then this y squared that we saw, we're going to put it here in front of that x squared because that's just typically the way that we're going to write that kind of, your square root's always going to be at the end. Sorry guys, I'm recording this on Friday and you know how bad of a day that was for me. Okay, let's try another one. I'm going to change the color that I'm writing it in. So we have got the cubed root of a to the 6th, and we've got the cubed root of b to the 12th. Okay, Can I divide 6 by 3 evenly? Yes. I get a squared. That takes care of that. Can I divide 12 by 3 evenly? Yeah, 12 divided by 3 is 4. So b to the 4th. So if they'll divide evenly, they're nice and quick. All right. Let's change colors again. So here I've got the cubed root of x to the 9th times the cubed root of y to the 11th. All right, can we divide 9 by 3 evenly? Yes, we can. That gives us x to the 3rd. Okay. Can we divide 11 by 3 evenly? No, unfortunately we can't. So I'm going to do my y to the 3rd, y to the 3rd, y to the 3rd. That's 9. I need 2 more to make 11. Okay, so let's make sure that we're clear here. 3, 6, 9, 10, 11. Okay, so how many y cubes do we have? 1, 2, 3. So y cubed, that cube right there, this is because there are 3 y cubes underneath. And then what's left is a y squared underneath. Okay? If you need to pause and talk to somebody about it, that's okay. Let's move on. Okay. Here we've got a number in addition. So let's do the square root of 4 times the square root of x to the 12th times the square root of y cubed. Okay. Square root of 4, we know that. That's 2. Square root of 12, can I divide 12 by 2 evenly? Yes, I can. That gives me x to the 6th. Okay. Can I divide 3 by 2 evenly? No, I can't. So I'm going to do a y squared, and I need 1 more y to make 3. 2 plus 1 is 3. So the square root of y squared is y, and that leaves a y underneath the radical. Okay, that's our final answer. Let's change colors and do this one. Square root of 24 times the square root of x squared times the square root of y to the 4th. Okay, 24 is not a perfect square, so I want you to look back at what we did on examples 1 through 3. Okay, I'm going to break this into 2 factors. Just to save room on my board, I'm not going to go through all the process. If you want to pause it, do your process where you find your factors and pick them, that's fine. I'm going to do the square root of 4 times the square root of 6. The square root of 4 is 2. It's going to leave me a square root of 6 underneath there. Now notice I'm leaving some space there. I'll get it out in a minute. Okay, so I've written both of those. Square root of x squared. 2 divided by 2 is a single x that comes out of the square root sign. 4 divided by 2 is 2, so y squared comes out of the square root sign, and this is my final answer. Okay, again, guys, feel free to pause and go back through it. Okay, I know it's going a little fast. Here, notice that we've changed our index. So I've got the cubed root of negative 27 times the cubed root of a to the 4 times the cubed root of b to the 12. Okay, I'm going to go ahead and move this up a little bit, maybe. Okay, the cubed root of negative 27, if you put that into your calculator, you're going to find that is, I'm going to bring this over here, is a whole number negative 3. Okay, so we're done with that. Is 4 evenly divisible by 3? No, it's not, so we got to break it down. We have a to the 3rd, and I'm using a 3rd because that's my index. And we need 1 more. 3 plus 1 is 4. So the cubed root of a cubed gives me a single a outside, but I still have an a underneath. And then is 12 divisible by 3 evenly? Yes, it is. Leaves me b to the 4th. Okay, so here are examples. If you need to talk with somebody, talk through the examples. You guys have each other in class. I want to be sure that you know only the last piece of the homework actually is doing this. The first two pieces are from last week. Okay.